Okay, good morning everybody. Hopefully by the time you guys start looking at this, I'll be on my way. It is Thursday for me right now because I'm recording it, but for you guys right now it's Monday morning. I should be driving home from California, and hopefully everybody had a good weekend. So to talk about this lesson that we're going to talk about, this is called the elimination method, but there really are three ways. There are three ways to find the intersection of two lines. Okay? Go ahead and write that down. There's three ways. And all three ways work. Graphing is probably the least effective. We've talked about that in class, but go ahead and write that down. Three ways to find the intersection of two lines. So graphing is probably the least effective. For one, you got to take out a piece of graph paper, right? And you graph your lines, right? You got to solve for y or do the, and then you get some lines that intersect, and you're not quite sure where they intersect. So graphing is the least effective. That's the first way. Second way, which works really well, is the substitution, which we learned last week. And the third way is by elimination. These two, substitution and elimination, work really well, but it all depends on the problem. When I take a look at this example, what I notice on this particular example is the 2y and the minus 2y. They're opposites. I would not do this one by substitution at all. I would do this by elimination because I know, I want you to see this, 2y, positive 2y, negative 2y. If I were to add these two equations just straight down, 3x plus 3x, 2y minus 2y, 4 and 12, then the y's would be eliminated, okay? So then I'm just going to add because I see the opposites. They'll eliminate each other. I'll get a 6x equals 12. Divide by 6. Divide by 6, I get x equals 2. Now again, the answer is a point. So my answer is 2 something. So to get to something, I am going to substitute because that's really the easiest way to finish this. So I know x is 2, so I can plug my x either, doesn't really matter, either into equation 1 or into equation 2. 4x, I'm either going to put my 2 here or my 2 here to find the value of y. So it does not matter, honestly, but I think equation 1 looks easier because there's no negatives. So I'll take equation 1, which is a 3x plus a 2y equals 4, and I will substitute my 2 and put my 2 right there. So I'm going to rewrite this as 3. I'll put my 2 right there for x plus 2y equals 4. Okay, so I'll put the 2 in for x. Not write x, but write what x is equal to. Substitute it in. 3 times 2 is 6 plus 2y equals 4. I'm going to continue solving. Minus 6 minus 6. I'll have a 2y equals negative 2. I'll divide by 2, divide by 2. I get y equals negative 1. Awesome. Easy. But it only works because of the opposites, okay? It only works because of the opposites. That's what makes elimination so nice. Now, look at example 2. The same thing. What I see looking at this problem is the 3x and the negative 3x. So these problems are unique. Elimination is the best method because 3x and negative 3x, they automatically are going to cancel. I see that, so I'm going to add them. Add them so you count 3x and a minus 3x, they cancel out. 2y and 4y makes a 6y. I get 7 plus 5 is 12. Divide by 6, I get y equals 2. So again, my answer is some point, something, 2, and I want to make sure I put the 2 in for either one. It doesn't really matter, either equation 1 or equation 2. I like equation 1, it looks easier, so I'll put my 2 right there for that y. So I'll rewrite equation 1 as 3x plus 2y equals 7. I'll put my 2 right in for the value of y. So instead of writing y, I'll write 2 in its place. 3x plus 2, and I'll substitute the 2 in for y. I'll go 3x plus 4 equals 7. Minus 4 minus 4. 3x equals 3. Right? Divide by 3, divide by 3. X equals 1. Okay, so there's my answer. Okay, kind of fast. I'll slow down. Sorry, you guys. 2 times 2 is 4. Then I solved minus 4 minus 4. Gave me a 3. Divide by 3, divide by 3. X is 1. Okay, now, example 3 is a little bit different. And the reason it's different is because if I add straight down, well, look, if you add straight down, it won't cancel. Those won't cancel. Those won't cancel. So you do this thing called the multiplication elimination method. So I'm going to multiply either equation, but what I see is if this were a 6y. Look, check it out, 6y. If that were 6y, negative 6y, they would cancel, right? Okay. So what I'm going to do is, I'm going to text Braden real quick. So if I were to make this a 6y and a negative 6y, they would cancel. So I'm going to multiply equation 1 by 2. So equation 1, equation 2. And if I multiply everything, then I'll get a 6y. So let me rewrite this. So then equation 1 now is a negative. You've got to multiply all the way. Negative, everything. Negative 20x plus 6y equals 2. Multiply everything through. And then equation 2 I don't need to do anything with because I really just need this negative 6y. So I'm going to keep equation 2 the same. Equals 23. And now my goal was to make something cancel by elimination. These two will eliminate, so I'm going to add. So I'm going to get a negative 25x, cancel, cancel, equals a 25. I'll divide by negative 25, divide by negative 25. X is equal to negative 1. Okay, so there's part of my answer. My answer is negative 1 something. Okay, to get the something, I know x is negative 1, right? So I can plug it into any of these equations. Actually, I kind of like equation 2 better this time with smaller numbers. So I'm going to plug it into equation 2. Again, it does not matter. You can plug it into any of these 4, actually. I like equation 2, it's just smaller numbers. So I've got negative 5x minus 6y equals 23. I want the value of y. I know x. Put my negative 1 right there for x. So I'll go negative 5. Instead of writing x, I'll write what x is equal to. I'll substitute negative 1 into it. Okay. And then I'll go 5 minus 6y equals 23, right? I'll go minus 5 minus 5. I'll get negative 6y equals 18. And then I'll divide by negative 6. And I'll get y is equal to negative 3. How am I doing? Okay. So far, so good. All right, that's my answer. Let's turn the page. Okay. All right, example 4. Elimination method. Well, okay, eliminate. But if I put the x's together, they don't eliminate. If I put the y's together, they don't eliminate. Hold on, let me turn off that. So here's what I have to do. If I could make this a 6x and this a negative 6x, that'd be the easiest. 6x, negative 6x. So I'm going to multiply both. So multiplication method, I'm going to multiply, okay? I'm going to multiply first the top equation, equation 1, by 2, because that'll make a 6x. I don't care about the rest. And I'll multiply this equation by 3, because that'll make a negative 6x. Okay, so equation 1, equation 2, the idea is to eliminate. So I'm going to go ahead and do that. I'm going to go ahead and rewrite equation 1 as, multiply it all the way through as a 6x plus a 22y equals 8. And then a negative 6x minus 15y equals 27. Okay, how am I doing? So I'm going to, now if I add, they'll eliminate, which I like. They're going to completely eliminate. 6x minus 6x cancels. That's why I did this, so they eliminate. Let's see, 15 and 22, what is that, 7? That's a 7y, and I get a 35. 27 plus 8 is 35. And then divide by 7, and y is equal to 5. Okay? Alright. A few distractions here this morning, guys. Sorry about that. Now, if I know y is 5, I can put it into any of these equations. It does not matter. I think I'll put it in equation 1 because there's no negatives. So equation 1, which is my 3x plus 11y equals 4. It doesn't matter which equation you put it in. Not at all. I just like equation 1 because it looks easier. So I'm going to put my 5 right there because that's what y is equal to. So we're at 3x plus 11 times 5 equals 4. I'll do a 3x plus a 55 equals 4. Minus 55 minus 55. I'll have a 3x equals negative 51. I'll divide by 3, and x is, I think that's negative 17. So here's my answer. As a point, remember it's a point that we graph, that we never graph, that we know the answer is where two lines intersect. They intersect at negative 17, 5. Okay? Awesome. Hopefully this seems easy. Okay, example 5. Okay, on example 5, okay, a business, let me get my notes out real quick. All right. So a business with 2 locations buys 7 large vans and 5 small vans, okay? A location receives 5 large vans and 2 small vans for the cost of this, okay? So location B is 2 large vans and 3 small vans. So let's just make X and Y. It's easier than V and V1, V2. So let's just go, okay, X is going to equal large vans, and Y will be small vans. Let's see how this actually works. So one location is going to be 7 large vans. Location A, sorry, 5 and 2, 7. So I got a 5 large plus 2 small for a cost of $235,000. And then location B has 2 large vans and 3 small vans for a cost of $160,000. Okay, so I should be able to solve and find out the cost of each. So I'm going to do it by elimination. I think if I multiply the first equation by 3 and the second equation by negative 2, let's see why I wanted to do that. 6, negative 6. You guys see that? 6, negative 6. And so let me go ahead and rewrite equation 1 and equation 2. I'd have a 15x plus a 6y equals, oh, I need a calculator. Give me a second. I need a calculator. Let me do this. Clear. 235,000 times 3 is, looks like 705,000. And then I'll have a equation 1, equation 2, multiply through the negative 2. I'll have a negative 4x minus a 6y equals 160,000 times negative 2 is negative 320,000. Now if I add them, I'll get 11x. These cancel. That's the whole idea, is to cancel one of them. And then I'll go 705,000 minus your 320,000 gives me a 385,000. Divide by 11. Divide by 11. I'll divide by 11. And I get $3,500, okay? X equals $3,500. $35,000. About the price of a van, sure. That's a large van. So to find the small van, that's my large van. That's the price of my large van. The price of my small van, let's plug this into, say, how about this one? This one looks easier, okay? I plug that into that one in equation 2. I'd go not 2x, but 2 times my large van, which is 35,000 plus 3y. So I'm running out of room. Hopefully you guys are writing smaller than I am. All right? That's 70,000. I can do that in my head. Plus 3y equals 160,000. I'm going to go minus 70,000, right? I'm just solving. You guys know what I'm doing. You should. We've been doing this for a while. 160, 1, 2, 3, minus 70,000. I get an answer of 90,000. Oh, okay. Divide by 3, divide by 3. So a small van is 30,000, okay? So my large van and my small van. Sorry, it's all kind of like, squished around there because I was running out of room. I wrote too big, but there it is. Okay, now today, you guys need to work on this. Today, homework. I'll be back tomorrow. You need to do this. You need to do page 135, homework, out of your journal, page 135. I want you 1 through 19 odd. Odd means, 1, 3, 5, 7, just the odds. Okay, that's all I have for you. You guys have a great day. I'll see you tomorrow.